In this video, we're going to try to prove that two triangles are congruent to each other. We've got a picture of these two triangles, and they look like they're congruent, but can we prove it? That's what we're going to do. Now, we're given a few statements. The first one over here is that C is the midpoint of BE, so we can see that C is in the middle of this long line that sends across the two triangles BE. Then we're given that angle B is congruent to angle E, so that's angle B on one end of this triangle and angle E on one end of this triangle. And then lastly, we're given two lines. Line AB is congruent to DE. So AB, again, is on the triangle on the left, and DE is on the triangle on the right. So we've got those three statements we're given, and then lastly, we're told explicitly what we are trying to prove. So that's triangle ABC is congruent to triangle DEC. So that's all we're given to work with, and other than just looking at the picture, how do we put this together? So there's a few things that we know about triangle congruence. We know a handful of postulates that tell us that triangles can be definitely said to be congruent. So for example, there's side, 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 which is when you've got three sides of one triangle that are congruent to three sides of another triangle. There is also side angle side, and that is when two sides and the included angle are congruent. There's also angle side angle. And then there is also angle side. So these are just basically four different ways of showing that triangles are congruent to each other. And so when we know we have to prove that two triangles are congruent, we're trying to figure out which one of these four is going to be most useful based on what we know about these two triangles. So in this case, we know that they share a congruent angle, angle B and E. They share a congruent side, A, B, and D, E, and that's all we really know right off the top of the bat. So we know an angle and a side. Since that's the case, it's probably not going to be side, side, side. That's going to be a harder one to prove just because we don't know multiple sides yet. So I say just rule that one out. Also going to rule out angle, angle, side since we only know one angle, and same thing with angle, side, angle. And I'm just kind of speculating here. I mean, it may prove that that's actually one of these is the best one, but let's hone in on side, angle, side. And the reason for that is we've got this side, we've got this angle. So if we just had one other side, we could prove that these two triangles are congruent. And that's where we look to what else we're given in the problem. And we're given that C is the midpoint of BE. So what do we know about a midpoint? Well, a midpoint is the middle of a line. So that means that the two segments that it creates, so point C creates segment BC and CE, are going to be congruent. So we can draw that on the triangles like this. And now look what we have. Side, angle, side. So we just kind of talk through that. So this is the one, side, angle, side. That's what we're going to do. But now we have to put that into an actual proof. So let's go through that process. We create our little table. So we start with a statement column and a reason column. This is all geometric proofs. So we're going to look just like this. And then we add a bunch of boxes. And we don't know exactly how many statements we're going to need. It doesn't really matter how many boxes you add. You can kind of do this however you want. But let's just add a bunch of boxes and then we'll fill in as many as we need. And we basically just have to take what we just talked through and put it into this table that is just our evidence. It's basically like building our case to say that these two triangles are congruent. So the first thing we're going to do, and it doesn't really matter what order you do this in, and you can have the same proof or the same thing you're trying to prove by different people, and they'll list statements in different orders, and that's perfectly okay. It's really just about making sure that all of the things that you need to say are in there. All of the kind of bits of evidence are kind of presented, you might say, in order to be able to definitively prove what you're trying to prove. We're going to start with saying C is the midpoint of BE. And the reason for that is it's given. Anything that is in the problem as given, that's all the reason you need. We're told that that's true, so therefore, for the purposes of this proof, that's true. Next, we can say that BC is congruent to CE, and so that again was what I drew over here. And why can we say that? So that's not given to us, so we have to give some type of reason based on what we know about geometry. And so, like I said earlier, we know that's the definition of a midpoint, that if you have a midpoint of a line, then the two lines formed by that midpoint are congruent. So just saying definition of a midpoint is all we need to say. So now we've made that statement. Now we've basically proven that BC is congruent to CE. Then let's throw in angle B is congruent to angle E. Again, that's just one thing that's given to us in the problem. And then let's throw in that AB is congruent to DE, and that is also given in the problem. And then now what we have here is our side, our angle, and our side. So we have to have these three things said in our proof in order to then say triangle ABC is congruent to triangle DEC, and we can say the reason is the side angle side postulate. And that is pretty much it to doing a proof. Again, you could do these in any order. You could list angle B is congruent to angle E first. You could list that side AB is congruent to DE first. Just whatever follows has to be either given in the problem or based on something you already said. So in order to say that BC is congruent to CE, I have to give this reason of C is the midpoint of BE. And that's pretty much all there is to writing a geometric proof.